one. We're going to talk about knowledge management systems. Why is it important for organizations to gather and disseminate knowledge? We get a little bit into different types of business intelligence tools and analyses. So, for organizations, gathering the tacit and explicit knowledge that they have floating around in the organization. Now, your explicit knowledge is the information that's written down in employee handbooks, procedures. It's the information that's very clearly written down somewhere. The tacit knowledge is the knowledge that hangs out in people's heads. It's the knowledge about how to do things in a way that is most expeditious. It's the knowledge that people gather as they do their jobs, best practices. How do you do these processes these different business processes in a way that is expeditious, that is productive, and getting that information outside of people's heads and in a place where you can share it with others is important, and it's also a challenge. Okay, so currently the business environment we find ourselves in is an information environment. Okay, we have an information economy. A majority of our businesses run on information. A big part of it was the internet and the push that the internet created the technology as a technology to create collaborations between businesses and their customers. And a big part of a lot of organizations, their actual value comes from these information assets, comes from all of the different types of information that the business generates, that the business has. Okay, and it could be things like tangible or intangible assets, their knowledge, their brands, trade secrets, information about how the business processes. An organization that invests in and executes a knowledge management project well can see very large return on investment. Okay. So knowledge management is actually one of the fastest growing information system areas. Okay. When we think about knowledge in general, knowledge is an asset. Okay, it has the knowledge that organizations generate, the knowledge that they hold, actually has a value to them. Okay. And a lot of this is intangible knowledge, okay? Not just intangible knowledge, but it's knowledge that's in different parts of the organization. It's scattered, it's in different systems. So these knowledge management systems are a way of getting all that information into one place and being able to disseminate it throughout the organization. Okay? Knowledge has different forms. Again, it can be explicit or tacit. Knowledge can be know-how, actually knowing how to do some craft or skill. It can be following some procedure, or it could be about knowing why things happen. Okay, and all of that is knowledge that the organization, that an organization may be interested in keeping and disseminating. Okay, most knowledge has a location. Okay. It can be social or individual, so the knowledge could be something that everybody in the organization is aware of, maybe procedures or the way that they do things. It can be information that single individuals have that they share. A lot of knowledge in an organization is sticky. It's hard to move from one place to another for different reasons, maybe because it's in somebody's head, and you have to know that they have that information and ask for it. A lot of it's situated. It's really enmeshed in the culture of the organization, and a lot of knowledge is contextual. So it's going to work in different situations. Okay? Knowledge is also situational. Okay? It could be conditional, so it could be knowing when to apply a particular procedure, or contextual, knowing certain circumstances, when do you use a certain tool kind of knowledge. Okay? So for an organization, knowledge management helps them. Having a good knowledge management plan, not just a system, but a whole process for how they deal with their information, can help an organization to create competitive advantages, to increasing their profits. Okay. Now, when we talk about knowledge, we can think about this concept of wisdom also, which is a way of applying knowledge to solve problems. Okay. So wisdom is not. It's about knowing having knowledge and knowing how to actually apply it. Organizations, we also have to think about the fact that organizations as a whole, there's processes in which organizations learn. And when you say organizations, we're thinking about how organizations maybe adapt to new to circumstances in business environment. Some organizations are very adaptable. They're able to make changes in regards to new challenges or technologies that show up. Okay, but organizations all have processes in which they learn. Okay, and some of them, and they need to be able to adjust their behavior based on the experiences that they have. It could be something like creating new business processes or changing the patterns of the way that management makes decisions. Okay? So your book defines knowledge management as a set of business processes that are developed in an organization to create, store, transfer, and apply knowledge. And there is a value chain for knowledge management, 4 different stages in which you go from acquiring knowledge to actually using that knowledge. Okay? So you have knowledge acquisition, the storage of that knowledge, the dissemination of that knowledge, and then the application of it. And this is understanding about this knowledge value chain, going from acquiring that knowledge and getting all of it into one place to actually applying that knowledge is important, because that's the process that these knowledge management systems take. Okay, and knowledge management is not just a system, but it's also a whole set of processes for how do we, when we have information, how do we get that information into a way that we can share it across the organization. Okay, so we're going to take a look at each one of these stages in the knowledge management value chain. So for acquisition, it's where you're documenting tacit and explicit knowledge, and this can be unstructured documents, things like emails. It could be stuff like documents, reports, presentations, best practices. All of those fall under the category of knowledge. Okay. We'll talk a little bit about a knowledge management system where you're actually developing an online sort of directory of experts. If you have different experts within your organization, how do people get access to those people? So there's actually a specific type of knowledge management system that does this. Okay. With knowledge acquisition, you're also looking at getting in data from different systems, including transaction processing systems and external sources. So knowledge management, you're not just looking at your organizational information, information from your systems, but also bringing in external information to supplement that. Okay? With knowledge, once you acquire that knowledge, you have to create some kind of database to store it. A lot of knowledge management systems have, kind of have an integrated database in there. When it comes to knowledge management systems, management has a specific set of tasks that are set forth for them to help make these knowledge management systems successful. Okay, it includes supporting the development of a knowledge management system. So for any information system that an organization decides to invest in and to implement, for it to be successful, they have to have management support. Okay, and the knowledge management system is no different. Okay, they should encourage the development of corporate-wide schemas for indexing documents. So not only do you have to acquire the information, but you have to figure out how you're going to store the information so that it's available. How is it going to be made available? What is the classification scheme? Okay, just has to do with creating the database and what categories of information are you going to store. And of course, rewarding employees for actually utilizing the knowledge management system, for adding to the system. With knowledge management systems, there are some employees that may be a little bit, that may not want to add their tacit knowledge to the knowledge management system. If you have, as an employee, you might feel like that having that information makes you, is a level of job security, right? Once that information leaves your head and it's available for everybody, maybe you lose that job security. So with knowledge management systems, for them to work, there do actually need to be reward systems in place to encourage people to add to those systems. Okay? Once the information's in there, it's properly indexed, people are using it and actually contributing to it, you have to make that knowledge available to employees. So once you have it, you have to make it available so people can actually use it. They can get access to those best practices. They can utilize that information in their day-to-day jobs to hopefully increase their productivity and make better decisions. So some of the ways that knowledge management systems make that information available include things like portals, maybe having some sort of push email report that goes out to everybody in the organization, creating some kind of search engine so that when you go into the knowledge management system, you can put in keywords just like any other search engine to find information about certain topics. A lot of knowledge management systems incorporate collaboration tools that allow people to utilize the information, but also to share additional information, collaborate with one another. Okay. One of the issues with any system that deals with information and large amounts of information is the fact that all organizations create large amounts of information, and so you have to be able to figure out what information is important, and managers tend to do this naturally. As individuals, we have filters in regards to information that we pay attention to and information that we don't. Okay, and managers, when it comes to organizations, they have these same type of filters in regards to organizational information. Okay, but you could end up with this deluge of information, having so much information, being overwhelmed with it. So you have to figure out what information is important for you. And then, of course, the last step is the actual application of the knowledge. Once you have it in the system, once it's properly indexed, once it's being disseminated among the employees of an organization, right? How do they actually implement that into their business processes? How do they implement that into their day-to-day operations? Okay, and once you actually start to apply best practices and other types of information that knowledge management systems can make available to you, you can create new business practices, maybe change the way that you're doing things because somebody found a way of doing it better, right? Creating new products or services, coming out of suggestions from employees, right? We have this service, why don't we add something that goes along with it, right? Or, even discovering new markets, right? Having a product mix and figuring out new uses for the products that you have, right? You can have a product that if you figure out a new use and it catches on, right? You can give that product a whole new life and possibly make it more profitable. So this is the value chain, and kind of take a look at that. Knowledge management can also create new roles within the organization. Just like security, just like general information systems, knowledge management in large organizations, you can have a chief knowledge officer. You can have somebody who is their whole job is to deal with your knowledge management processes and your systems. Possibly just having dedicated staff and managers that deal with knowledge. Now, communities of practice. A community of practice is an informal social network. It's people that get together because they have information to share. Maybe they do the same job, and they want to share the ways, best practices that enable you to do the same job but do it better. Okay. There's actually. Actually, there's a whole area of research in regards to communities of practices that have sprung up. Groups of people that have the same interests, whether it's job related or otherwise, that want to share information with one another. Okay. Now, these knowledge management systems can help to facilitate the creation of communities of practice within your organization, okay? Helping you to reducing the learning curve of new employees because you have information that is available to them, facilitating the reuse of knowledge, having in other activities, and kind of building upon the knowledge that the systems have and make available to the organization. Now, there's three different major types of knowledge management systems. There's the enterprise-wide knowledge management system. This is sort of a general purpose knowledge management system that an organization can decide to implement. You have a knowledge work system, and this is a more specialized type of knowledge management system built for a more specialized group, engineers, scientists. And then, of course, you have intelligent techniques, and this is where we're actually going to talk about some specific techniques for discovering knowledge and other types of optimal solutions. Okay, so this just looks at each one of these different types of systems, your enterprise-wide, your knowledge work systems, which are the specialized ones, including things like computerized, computer-aided drafting, 3D visualization, virtual reality, and then your intelligent techniques. And we're actually going to look at some of these different types of techniques: neural networks, expert systems, genetic algorithms. We're going to talk a little bit about each one of those in a little bit more detail. So the three major types of knowledge in the enterprise, and we kind of talked about this before, but it was structured documents, semi-structured documents. So structured documents, formal, formal reports, presentations, handbooks, stuff like that. Semi-structured information, which is more like your emails and videos. And then unstructured tacit knowledge, which, to be honest, is probably the hardest of all of the three types of knowledge to gather. But 80% of an organization has their information as semi-structured or unstructured. Okay, and that's really one of the challenges with knowledge management systems, because the information, if it's semi-structured or unstructured, a large portion of your information, it makes it harder to actually acquire and classify and make available that information. Okay, you have enterprise content management systems, which help you to capture, store, retrieve, and distribute and preserve information. Your structured and semi-structured information. These enterprise content management systems also bring in external information, other, research, news feeds, things like that, to kind of to add to your internal information. And these types of systems also have tools for communication and collaboration, which knowledge management systems in general tend to have those types of tools available. Okay, so this is generally, looking at how an enterprise content management system users get access to. They can create and capture, they can tag, store and retrieve, manage and review, and distribute and publish information. So these are the things that the users can do with the information, and there's a, kind of a large repository of all of that information available to users through this content management system that includes all of these different types of information. Okay? One of the big problems with these types of systems is actually developing what they call a taxonomy, which is a classification framework for how you're going to label and classify the information that you put into the system. Okay, that tends to be one of the harder steps in developing these systems. Okay, you also have digital asset management systems, which are systems that focus more so on digital information, photographs, graphics, audio, and video. It's a specialized content management system. Okay. The second type of knowledge management system is a knowledge network system. A knowledge network system creates a way for employees within an organization to find experts in different areas. So it's an online directory of your corporate experts. Who knows about this particular area? Who knows about this area? Right? So instead of getting that information into the system, you are trying to identify experts within the organization. They utilize communication technologies that make that type of communication between employees easier. And it may actually have some solutions that are developed by experts actually in the system itself, including things like best practices and frequently asked questions or FAQ stuff. Okay, so this is the enterprise knowledge network system, and again, you have subject matter experts, different types of experts in different areas of the organization. The system allows users to find those experts, to locate them within the organization. Also stores some best practices, frequently asked questions, other types of expert-developed knowledge that's actually available within the system itself. Okay. Now, these types of systems may also use some of the collaboration technologies that they use include some of these consumer web technologies, blogs, which are online journals, wikis, which are web pages that anybody can make changes to, and social bookmarking is this idea that you find web pages that are web pages or web resources that fit into certain categories, and you can save that, you can bookmark those resources and actually tag them with keywords. So it's a way of individuals manually classifying web resources, okay? And you have these types of capabilities within these systems, okay? Learning management systems, another kind of part of these types of systems are learning management systems within organizations. Education and training tends to be a big part of what they do, whether it's educating new employees about how we do things or continuous educating of procedures to remind people over time this is how we do things. So they have systems that, and actually learning management systems, Blackboard technically is an LMS, a learning management system. So you guys have all been, have utilized a learning management system, okay? But it has tools for management, delivery, tracking, and assessment of different types of learning and training. So you can kind of think about the different pieces that Blackboard has in it, right? It has file management in there. If, as the instructor, I can put blogs, I can put wikis, I can upload videos, I can make, there's a lot, create discussion forums, create groups, things like that. So there's a lot of different tools that are available in these learning management systems. And it supports different types of learning. It supports online learning, it supports video, live forums or live instructions, stuff like that. So it helps to automate some of the administration of these different education and training that organizations need to keep to utilize within their operations. Okay. The third type of knowledge management system is a knowledge work system. And this is a system for knowledge workers to help create new knowledge and integrate that into the business. So a lot of the individuals who utilize information are called knowledge workers. And there's researchers, designers, architects, students, scientists, engineers, anybody who creates knowledge for an organization is a knowledge worker. Okay? And knowledge workers have three major roles: keeping the organization current in knowledge, serving as internal consultants for certain areas of expertise. So if you and that's that knowledge network system helps organizations to keep track of those internal consultants and act as change agents to promote change projects. So to promote change within the organization, if there's some kind of external business influence that deems that change is necessary. So some of the requirements for knowledge work systems: substantial amount of power, of computing power for graphics and complex calculations, powerful graphics and analytical tools, communications and document management, which actually you're going to have that in any knowledge management system, access to internal databases, access to internal information. Every system, you always want it to have user-friendly interfaces. Optimize for whatever task it is that you're going to perform. So, designing the system so that it works with the particular business information and the business that it is implemented within. So this is a look at the requirements for knowledge work systems. You have your external data knowledge base, a hardware platform, and the actual knowledge work system with the software and the user interface that interacts with that software. Okay. Some examples of knowledge work systems include computer-aided design systems, which are used for engineering and architectural designs, virtual reality systems, simulations, 3D, medical modeling, augmented reality systems, and investment workstations, which they streamline investment processes. Now we'll talk a little bit about some of the techniques that are utilized within some of these systems to help to generate knowledge. Okay, so your book describes intelligent techniques itself as intelligent techniques are used to capture individual and collective knowledge and extend that knowledge base. So it's not just collecting that information, but actually potentially creating new knowledge. Okay. Intelligent techniques are used to capture tacit knowledge, and expert systems, case-based reasoning, and fuzzy logic are the techniques that are used for that. Knowledge discovery, you have neural networks and data mining. Generating solutions to complex problems, genetic algorithms help to do that. And automating tasks, intelligent agents. And we're actually going to talk a little bit about each one of these. Okay? Artificial intelligence also comes under, artificial intelligence is the classification that all of these different types of intelligent techniques come into play. And these are computer systems that emulate human behavior. Okay? So expert systems. Expert systems try to capture the information of an expert in a particular domain. Expert systems tend to be very limited to one or maybe two domains. Okay, so you're trying to get the set of assumptions and rules for decision making that an expert utilizes when they are making decisions in a particular domain. Okay, and it is a very expensive type of system to implement because it takes a lot to try to get information from experts and turn it into rules that an expert system can utilize. Okay, expert systems are used for discrete, highly structured decision making. Okay, so expert systems, because they're expensive to implement and utilize, they're very limited in their focus. You have to have a particular, a very specific use for an expert system. Okay, these are some of the technique. This is looking at some of the rules in an expert system, right? And this one here talks about credit, making decisions in regards to whether or not you would grant a credit line, whether you would limit it. So you have these different inputs of information that get applied to different rules within the expert system, and it comes out with decisions. Okay. And if you take a look at this, they're very, very specific rules. I mean, this is a very specific type of system for a very limited use. Okay? Expert systems have two major pieces. They have a knowledge base, which is all of the rules that they utilize to come up with those decisions, or their recommendations, really. And they have an inference engine. Okay, and the inference engine is how you actually search, how the system searches the knowledge base. There's two different ways that an inference engine can search a knowledge base. Okay, one's called forward chaining, which is where you expect the inference engine gets information from the user and then starts to search the knowledge base to arrive at a conclusion. Okay, so you start with the problem, you search the knowledge base to try to figure out a solution to arrive to that solution going forward. Backward chaining, you start with a hypothesis. A hypothesis is a belief in something that will happen, or it's a theory, really. Okay, so you start with a theory, and then it starts to ask questions to get information and either confirm or disprove that theory. So it starts backwards. It starts with a theory, and the information either supports or disproves that theory. Okay, so those are two different ways that expert systems can actually search their knowledge base. Okay, and this is looking at an inference engine, right? Different rules coming up with some kind of result or recommendation. Okay. We have an example. Your book talks about an example of a successful expert system. The Conway Transportation created a system to automate their route planning for their transportation. Most expert systems deal with problems of classification. So most expert systems deal with problems where you have relatively few outcomes, and the possible outcomes are known in advance. So it's very structured decision making. Okay, making a decision where you understand what the possibilities are. It's just helping to apply rules to figure out which outcome or which possibility applies to a particular situation. Okay. Most expert systems, they require a lot of. They're very expensive to develop and to maintain. Okay, because again, you're actually trying to get information from an expert's head and turning that into very specific rules for a particular domain. So in some cases, it might just be cheaper to actually hire human experts and use them instead of trying to implement and utilize this type of system, because it's very expensive. Okay. Another technique is called case-based reasoning. Okay. This is where you have a collection of past experiences, cases that are available within the system. The system will search for cases that have characteristics that are similar to the problem that you're looking at. Okay? It'll find a fit that's close to what you have, so it basically has a set of cases. It tries to find something that is close to the particular problem that you're looking at solving. It applies the solutions that were used in the old case. If it's successful or unsuccessful, now both of those cases, once you have a new case in the system, those two cases are get filed together. Okay, and when you have successful and unsuccessful solutions are both filed with that particular case. So it'll give you solutions based on previous cases, and if the solutions were successful or not successful, it puts all that together so that it's basically every time you add a new case, it's actually adding to the repertoire of cases and possible solutions that it has access to. Okay, and some of case-based reasoning is used in medical diagnostic systems as well as customer support. So if you've been on the phone with customer support and they're asking you questions and you can hear them typing in the background, a lot of those systems use case-based reasoning. Okay, and this takes a look at how case-based reasoning works. You have start with a problem. The system searches for similar cases, asks the user additional questions trying to narrow that search, finds the closest fit, modifies the solution to better fit the problem. Was it successful? Yes or no? Either way, it stores that information with the older case. Okay. Another intelligent technique is fuzzy logic. Fuzzy logic is a rule-based technology. It represents imprecise categories. So things like cold, cool, warm, hot. Those are imprecise categories with a range of values. Okay, it's used to describe a particular phenomenon or process, and then represented in a small number of flexible rules. Okay, fuzzy logic is utilized for solutions to problems where it's difficult to use some kind of if-then type of problem-solving technique. Okay, some of the The examples of fuzzy logic include autofocusing cameras, detecting possible medical fraud, and they give an example of a subway system that actually adjusts its acceleration control so that it has a very smooth, I think it's in Japan, it has a very smooth acceleration, slowing and stopping so that people aren't jostled as the subway is moving. And this takes a look at fuzzy logic for temperature control. And you'll notice that cold, this idea of cold, goes from 0 degrees all the way up to 60, but it overlaps with cool. Okay, and normal overlaps with this idea of cool and warm, so it's imprecise. These are the types of problems that are not very precise and that need to be represented in a different way, in a way that is more about kind of these overlapping categories. Okay, neural networks find patterns and relationships, and neural networks are utilized when there are huge amounts of data. Okay, huge amounts of data that are usually too complicated for humans to analyze. Okay, neural networks learn patterns. They search for relationships, build models, and they actually, as they go through more and more data, they can be trained and actually learn and change the models that they utilize to categorize information. Okay, humans can train it by feeding more data to it to help it learn by example. The spam filters within your email, okay, you can actually train the spam filters. If you get an email into your inbox that is actually spam, there's usually a button in there that says spam, and you can categorize it as spam. You're training your email filter that this particular type of email, if there's other emails that have the same characteristics as this email, they should be labeled as spam and they shouldn't go into my inbox. Okay, it's the same kind of idea. You can actually train it so that the tool itself learns and works better over time. Okay? And this takes a look at how a neural network works, and it's not very descriptive. It has an input layer where it takes in information, has a hidden layer, this is actually where everything happens, and then an output layer where it gives you results. Okay? I think it's interesting that they give you this visual where everything's happening in what they call the hidden layer. Okay? Genetic algorithms, these are useful for finding an optimal solution for a specific problem by examining a large number of possible solutions. Okay? Genetic algorithms are conceptually based on the idea of evolution. Okay? It searches among different variables that are changing and reorganizing those variables. It utilizes things like inheritance, mutation, and selection, so natural selection. Those are concepts that are utilized in genetic algorithms. Okay, it's used for optimization problems, trying to optimize for certain types of variables, minimizing costs, efficient scheduling, things like that. And it's used for when there are hundreds or thousands of different variables. Okay, so a large number of variables, it can find a solution. Okay, so this looks at the components of genetic algorithm, looking at some of the gives you an example of a genetic algorithm using this idea of chromosomes in here. Hybrid artificial intelligence systems utilize more than one type of intelligent technique. So you can, genetic algorithm, fuzzy logic, neural networks, expert systems. You can have systems that utilize 2 or more types of intelligent tools in that system. Okay. And then intelligent agents. Intelligent agents work in the background. They're usually carrying out some kind of repetitive, specific, predictable task. Okay. An example of an intelligent agent is a shopping bot, having a piece of software that will search for certain categories and deliver up information in regards to products, if prices change, things like that. But intelligent agents do a lot of this repetitive type of work without, that users, don't necessarily want to handle. Okay, things like finding the cheapest fare, right? Deleting junk email. This is an example. They give you an example of the intelligent agents in P&G supply chain network, where they have software agents in regards to their suppliers, which helps to schedule their deliveries. They utilize agents to collect real-time sales data at their retail locations, and they use software agents to schedule shipments from their distributors. So they actually utilize intelligent agents throughout their supply